Today we're going to look at how to write the equation of a rational function. Now, from what we've been talking about, remember rational functions are basically two functions. We have a top part and you have a bottom part. What we need to do is determine how do we get the top of the function and the bottom of our function. And to do that, it's very easy. To get the top of the function, what we're going to look at are the roots of the function. Now we have two roots here. We have one at -2 and one at +1. Now those are our roots, -2 and x equals 1. But be careful, the one at 1, it kind of goes back up, so it looks like it might be multiple, have a multiplicity of 2. So that's going to give me 2 or 3 roots down here. We had x plus 2, x minus 1 squared, and that will be the top of our function. To get the bottom of the rational, we have to find out where the vertical asymptotes are. And remember, and that's very simple to remember, because remember, to get the asymptotes, we looked at the bottom of our function. It was where the g of x would equal 0. So we look at our vertical asymptotes, and we have two of them. We have one at -3, and we have one at 4. Now, rationals, the vertical asymptotes also have multiplicity. So if I look at the -3, it's going down here and it's going up over here. So that's M1. The 4, on both sides of the asymptote, it looks like they're both going up. So that's M2. And that's going to help us write this. We get x plus 3 and we get x minus 4, but we're going to square it. So we have the top and we have the bottom. Next, we can actually start writing our equation. Y equals some generic constant a. We'll talk about that in just a little bit. And we're going to get on top, we're going to get x plus 2, x minus 1 squared. And on bottom, we get x plus 3, x minus 4 squared. Now, to get a, we can use the horizontal asymptote, or we can use a point. Now, if we actually have a horizontal asymptote, we can actually kind of use that. So if I take a look here, I do have a horizontal asymptote that's not 0. So it's y equals 3. There's my horizontal asymptote right there. So how does that help me get a? Well, look at here. The degree on top is 3. The degree on bottom is also 3. So they are equal, which means we use the ratio method to get our horizontal asymptote. So it's going to be the ratio of the top and bottom. So that kind of gives me a already, and it's going to make that a equal to 3, which is a horizontal asymptote. So to find a, we can either use the y-intercept or other point. Now the y-intercept here is not very good because it's also because we don't really quite know what it is, or another point, but because we know it's a horizontal asymptote, we can actually use the horizontal asymptote. So what do we get for our equation? Y equals 3, the top stays, x plus 2, x minus 1 squared, over x plus 3, x minus 4 squared. Yeah, I forgot my parenthesis up here too. Be careful with that. And there's our equation for our graph up here. And you can kind of verify that. Make sure the degree on top. Make sure, see if I take a look here. What's the degree on top? 3. What's the degree on bottom? 3. And what's the ratio? 3. Just coincidence. So there's our horizontal asymptote. So let's take a look at number 2 on the back. Same exact type of problem. So, to get the top of the rational, that should be spaced over. Look at your roots. -2, looks like it. It also has multiplicity, and looks like at x equals 5. So we get x plus 2 squared, x minus 5. To get the bottom, look at your vertical asymptotes. I get -5, and I get 2. Remember, vertical asymptotes also have multiplicity. The -5, no multiplicity, going opposite directions. This one, they're both going down. So that does have multiplicity. So I write out my roots, my bottoms, x plus 5, x minus 2 squared. So I start my generic equation, y equals some constant a, okay, times x plus 2 squared x minus 5, and on bottom x plus 5 x minus 2 squared. Now, take a look here. Again, the top has a degree of 3. The bottom has a degree of 3. This is our ratio. And if we look over here, we're going to use the ratio, so the horizontal asymptote will be the ratio. But if we look over here, we got the horizontal asymptote, y equals 2. And there's our ratio, which helps me to find a. So again, I just use the ratio in this case. So I get y equals 2, x plus 2 squared, x minus 5 over x plus 5, x minus 2 squared. All right. Now, in part 2, we're going to take a look at what if we have a slant asymptote or no roots. So please make sure you go back there and check those.